So suppose we've designed a component and we understand its basic expected failure rate is a Weibull distribution. We've determined through our product testing and modeling that our alpha is going to be 0.5 and our beta is 5,000 hours. So we understand the Weibull distribution, and we've previously calculated the expected value for that to know that on average our product will last 10,000 hours. So we understand the distribution and the average life of our product. That tells us a lot about our design, tells us a lot about our product, but it doesn't tell us how satisfied our customer is going to be, because we don't know what the design parameters were going into the process. So what were the customer's requirements? Let's assume for the moment that the customer did specify a number of hours. Hopefully it's below our design threshold, way below it. But let's assume our customer was looking for something that would last at least 6,000 hours. On its surface, based on the averages, management will applaud, say, well, the customer asked for 6,000, we've delivered 10,000. The question is, should we really be applauding? What's the probability that we'll meet the customer's requirements given the design parameters we've established? So to do that model, we basically want to know what's the probability that the X failure of a particular product will be greater than 6,000 hours as we go through. That's really what we want to know, because that's how satisfied our customer is going to be as we see our way through. Now, like all integrations, the probability under the Weibull curve is calculated as the integral from its low value to its high value. So normally the values we calculate are for X being less than something. So in this case, since we know we're looking for X being greater than something, and this is usually the case when we're looking at customer failure rates and defects, we know we have to take 1 minus some probability. So we know that this number is equal to 1 minus the integrated function for 6,000 hours. So you have to remember to do that, because when you're dealing with specifications, customers usually want to exceed some value, and all of our distributions and formulas are set up to tell us how much is lower. So always remember to calculate that by 1, or you'll get a very wrong answer to the question that management is actually asking. So to answer this question, we just have to substitute our integration formula for the Weibull distribution. So we know that it's 1 minus, and we can take the formula, which itself is 1 minus an exponential of minus x over beta, okay, to the alpha. And we close that bracket. So that's our basic function for doing that as we go through. So we can calculate that value. Okay, we can basically, we want that to be 1 minus 1 becomes plus exponents. These two 1s will cancel each other out. We end up with the exponential of minus, and our x in this case is 6,000, divided by our beta, which is 5,000. Okay, and we want to raise that to the alpha power, which is 0.5. So again, that turns into e to the negative 1095, which is 33.4. So the probability that our product will last at least 6,000 hours is only 33%, 33.4% basically. So while management was applauding the expected design life of 10,000 hours, it turns out that that design will only meet the customer's requirements about 1/3 of the time. That's not something you want to applaud. So it's great to calculate the expected life of a Weibull distribution, but you've got to take that next step then and compare and look at the probabilities under that distribution to know how often your design will actually meet the requirements of the customer. And in this case, it will only meet the requirements of the customer 1/3 of the time.